Okay, in this problem, we're going to go through a trig and related rates issue with angles. So first off, your calculator should be in radian mode when working on these problems. Okay, so I have a picture for you here, and let's read the problem together. It says the GC dance group just finished their final act by dancing off the stage with a rotating spotlight covering their every move. If the duo is moving off the stage along a straight path at a speed of 4 feet per second. So what is that they just told us? That is dx dt, and it is 4 feet per second in the positive direction because that x is getting larger. Okay, and the spotlight's 20 feet away from their path. Okay, that means y is 20. And by the way, the spotlight is always 20 feet away from the path. So therefore, not only is y 20, but dy dt equals 0 because that spotlight does not move. Okay, it may rotate, but it's always the same height. Okay, and this x is 15. All right, so then it goes on to say, at what rate is theta changing? So theta is your angle. So that's your angle at the top of the triangle. So at what rate is it changing? So I need to figure out d theta dt, but I also don't yet have theta. So I have to solve for this, and I have to figure out this. Okay, so at what rate is theta changing? When the duo is 15 feet from the point directly below the hanging spotlight. And then I'm asking you to round your answer to the nearest hundredth. All right, so with related rates, you have to establish an equation that relates the information. So in this situation, that equation would be the tan of the angle. And why is that the case? It's the case because, and we should probably write up here, so SOHCAHTOA is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. All I have so far is information about the opposite and about the adjacent. So I'm going to establish that tan of theta is indeed going to equal opposite, which is x, over y. All right, that's our relationship equation. It also will be our related rates equation, but we're going to use this twice. The first time we're going to use this, we're not taking derivatives. We are going to solve for the missing angle because remember I put a little blank there. So let's plug in what we have. So tan of theta is going to equal my x over y, and in this situation my x is 15, my y is 20. So that means if I'm going to find the angle, I'm going to have to use inverse trig, and this is going in your calculator, tan to the negative 1 of the fraction 15 over 20. Okay, you are in radian mode. So you're going to figure out when you put this in your calculator right here that your angle round to the nearest hundredth is going to be 0.64. So that's your angle, and it's in radians. So it is, get this to right, nope, 0.64 radians. Okay, so that goes there. All right, so we've now used this one time. We're going to use it again as a related rates problem because we need to find a related rate. We need to find d theta dt. So exact same equation. So may I, in order to use it again, I think what I'd like to do is get this out of here. Okay, so let me just say we're going to cut that. And then I'm going to say I still need that, and this equaled 0.64 radians. Okay, so look back if you need to see that other little piece, because we're going to use this equation again. Now it's related rates. So take the derivative on either side with respect to time. So tan theta, that derivative, is going to be secant squared theta. Okay, so it's going to equal secant squared theta, and it's going to be theta. Okay, and then d theta dt, and then we have to do our quotient rule. So we're going to say low, which is y, so I'm going to have to continue this down here. Okay, low d high, so that's going to be dx dt minus high d low all over low squared. Okay, so we've got that squared away. Okay, so let me take this, and we're going to do it on the next page because I need more room. Okay, so let me just scoot this over. Alright, so that's what we have so far. So let's clean this up. First thing I would do is I would write secant squared theta as 1 over cosine squared theta. So I'm going to put this in this box, and then we're going to work down here. So, and it'll become obvious why we're doing that in just a second. So this is going to be 1 over cosine squared theta, and I still have my d theta dt, and I have equals y dx dt minus x dy dt. Sorry, this was supposed to be dt. Let me get rid of that. dt all over, so this whole thing is over y squared. Alright, so I want to get d theta dt by itself, so I'm going to multiply the left-hand side by cosine squared theta. That will eliminate that fraction. Use your parentheses and multiply the numerator only by cosine. I'm going to write it like this just so I don't mess anything up. Okay, so now I'm looking at what d theta dt is. Let's start plugging in some values. Okay, look at y. Y was the 20 feet. That was the height of the rotating light. So 20 dx dt. So dx dt ends up being 4. So I'm going to put a little dot for multiplication. And then that's times 4. Minus my x was 15. My dy dt is 0. So that's going to eliminate that term. Okay, and I want to put this in parens. I'm going to divide the whole thing by y squared, which is basically 20 times 20. And I'm going to multiply the whole thing by the cosine. The angle we found was 0.64. And once we find the cosine, we're going to square that. Alright, so let's eliminate some things. I'm going to change to red. 15 times 0 is just 0, so that's gone. 20 goes into 20 one time. 4 goes into 20 5 times. Okay, so we can rewrite this one more time so that just for clarity's sake. So right now I know, and I'll write it over here, that d theta dt equals, all that's left in my numerator is cosine of the angle 0.64, and that term needs to be squared. All I have in my denominator at this point is just a simple 5. Okay, when you do that math, you end up getting d theta dt is 0.13 radians per second. So d theta dt ends up being 0.13 radians per second. Okay, and that's our answer. That's what we were looking for, how that angle was changing. Okay, so just note to self, these are trig problems. You're going to establish a trig ratio. You're going to then use that ratio twice. The first time you use it is to establish your identity of a missing value. In our case, we needed the value of the angle in radians. And the second time we use it is to do a related rates problem, and then you're looking for the answer to your question. And the question was, can you find d theta dt? Remember to round your answer to the nearest hundredth and to make sure your calculator is in radians. Okay, that brings us to the second problem. Okay, this problem we have to create our own sketch. So let's do that carefully. Okay, you've got two people, and those two people are 50 feet apart. Okay, one of them starts walking north. So let's have this person start walking north. Alright, so they get to this point. They were down here, and the other person was here. Now this space between the two people is not going to change down here. So this is going to become dx dt. That's always going to be 0. Alright, what else do we know? We know that a right angle is formed, because this is all right angle trig. And let's keep reading. One of them starts walking north at that rate, so the angle between them is changing at a constant rate. Okay, so this is the challenging thing. Here is the angle between them, right here. Because as this triangle opens up, initially there was a 0 angle between them. But as the angle is opening this way, the angle between them grows. And I know that it's growing at a certain rate, and the rate they gave me in the problem is that d theta dt is going to be changing at a constant rate of 0.01 radians per minute. They're also nice enough to give us the angle, which is always a good thing. So the angle in this situation equals 0.5 radians. Okay, so it says round your answer to the nearest hundredth. I'm sensing we may need more information. So let's see what they have for us. They want to know at what rate is the distance between the two people changing. That is this h right here. So that's what they wish to know. And I don't have a value for that. That's going to be the purpose of this problem, is to find that. Well, is it? No, that's not true. I need to first find that h, because the purpose of my problem is to find dh dt, the rate at which the people's distance is changing. So my problem is to find dh dt. Okay, so I'm not sure what that is. So that establishes what we have so far. We now need a trig function to work with. So I see I have an angle, I see I have the adjacent side, and I see I have to eventually get the hypotenuse, because I need to figure out dh dt. So in this situation, cosine is what I want to do to establish a relationship between all of these variables. So I'm going to say that the cosine of theta equals adjacent, which we're going to use just as letters right now, which is x, over hypotenuse. Okay, that's going to be the equation I use the first time through to get my missing angle, my missing side, and I'm also going to use it to work through my problem as a related rates problem. Okay, so let's plug in what we know. Cosine theta is 0.5, and that's going to equal 50 over h. So I'm looking for h. So h times the cosine of 0.5, that's going to equal 50. So if you want h by itself, h is going to equal 50 divided by the cosine of 0.5. Okay, so the cosine of 0.5, when I plug that in, I am getting an h that is equal to 56.97. So on this missing line, I'm going to put 50. Let's see if I can get this to right. 56.97. Okay, and that is going to be in feet. So I've gone through it once using my relationship. So that's this right here to establish the missing value, which was the value of h. So now we're going to use this relationship one more time, and we're going to use it as a related rates problem and get d theta dt. So I'm going to erase what I did here when I tried to solve for h. So let me just get this out of here so that I can redo the problem for what I need now. Okay, so our problem is to do related rates now. So the cosine of theta, that derivative moving from the left to the right, is going to be negative sine theta d theta dt equals. Now I have the product rule, so I'm going to do, the quotient rule, so I'm going to do that down here. So low d high, so that's dx dt, minus high d low, just dh dt, all over h squared. Okay, so let's see what we can do with this. I see that I want to, and I'm going to change my color for a sec. My goal is to get this dh dt. So right now, why don't we take this little piece, and we'll do this on the next page. So I want to cut all of this out. Okay. Okay, so here's our little problem. Okay, so let's see how we're going to do this. So I'm going to draw a little line so that we don't confuse ourselves. So I know that I have negative sine theta d theta dt equals h dx dt minus x dh dt all over h squared. So if I want to solve for dh dt, I'm going to move some things around. So how about if we do our cross products? So we're just going to say h squared, so h squared. Now I'm going to put this negative sign up top, times negative sine theta d theta dt is going to equal, and it's going to equal h dx dt minus x dh dt. Okay, so let's look at our picture and let's start working some things out. All right, so what do I know about some of these values? So we can start plugging in. So h squared is going to end up being, what, 56.97 squared. So I'm going to fill in below. So this is 56.97 squared times a negative sine, and what's the angle? The angle was 0.5, and then d theta dt. D theta dt is 0.01, so that's another times 0.01. All right, that's my left side. And let's see, dx dt, that is going to be 0. So if this guy is 0, then that means that 0 times h goes, and it's going to equal negative x times dh dt. So let me change back to green. And so that expression on the left will equal negative x, so that's negative 50 times dh dt, which is what I am looking for. Okay, so we can work this out. I'm going to end up dividing by negative 50. So since I'm going to have a negative over a negative, I know that the negatives will eventually cancel. Okay, so what will we have? We will have, let me see, okay, 56.97, take that quantity and square it, and since I'm dividing by a negative, I'm going to now drop the negative in front of the sign, because that's going to be a negative over the negative of the 50, which I also just dropped, and then multiply that by 0.01. If you do that math carefully, you will end up with dHdt equals 0.31 feet per minute. Now, I'm just noticing one typo, if you will. Okay, when I wrote this over, I should have said dH. Okay, so 0.31 feet per minute tells me how the distance between the two people are changing, and that is our final answer. Okay, let's go on to the third problem in this series. All right, so let's read through this problem. So a kite that's 100 feet above the ground moves horizontally at a speed of 8 feet per second. So that's our dx dt, and that is 8 feet per second. So this is our x, and this will be our y. All right, so at what rate is the angle between the string attached to the kite and the horizontal decreasing when 200 feet, so this is 200 feet, has been let out? Okay, so you see this angle right here? The ground and the kite are parallel, and the hypotenuse of that right triangle acts as a transversal. Therefore, the angle I just circled in blue can be placed inside the triangle, which is really helping us because that's where we need it. Okay, another thing I know, dy dt is 0 because the kite is always at the same height. What is it I need to find? I need to find h dt. So that's my hypotenuse. I want to know at what rate, I'm sorry, that's not true. At what rate is the angle between the string attached to the kite and the horizontal decreasing when 200 feet of string is out? Okay, so what am I trying to find? I know that the 200 feet is right there. Let me back up. And I am trying to find my d theta dt. But do I have my theta? So my theta is still needed, and I also need my x value. So I kind of need a lot of work right now. But ultimately, the problems ask me to find d theta dt, but I am missing theta, and I am missing x. And I need x because I have information about dx dt. So I definitely need theta, and I need x. So let's just look at this little right triangle. What do I have? So here's my little right triangle. In terms of sides, I know this is 200 and this is 100. So can't I get my x doing Pythagorean theorem? So I would say 200 squared equals 100 squared plus x squared. Solve for x, and you should end up getting an x equal to 173.2 feet. So this x is 173.2 feet by using Pythagorean theorem. Okay, so I'm going to write my x right here. 173.2, and that's in feet. Okay, so that was easy enough. Okay, so now, can I find my angle? Looks like I have a fair amount of information. So what I have, let's use the numbers that they gave me. Well, actually, take that back. Let's use the 100 that they gave me and the 173.2, which I just determined, so that we can use the trig relationship twice. So just like we have in the other problems. So what do I know? Tan of theta is going to equal y over x. And I don't yet know the angle. So tan of theta, still missing angle, equals y, which was a given, which is 100, over x, which is a not given, but we figured that out. So that means that my theta will equal tan to the negative 1 of 100 over 173.2. Okay, so that makes my theta equal to 0.52 radians. All right, so that's another piece of the puzzle. So the theta is 0.52 radians. Okay, so just like I've done previously, I'm going to erase this little piece right here because I used that to get the missing angle. So let's cut that out. Now we're going to go through the related rates problem so I can get what I need. So take your related rates equation, which means you're going to take the derivative with respect to time of all of the variables. So doing that gets me secant square theta d theta dt equals, quotient rule, low d high minus high d low over low squared. Okay, so just like we did last time, I'm going to change that secant to 1 over cosine. So let's just do that right here. I think I'm just going to erase the secant of the theta and make that 1 over cosine, and we were dealing with squares. Okay, now the reason why I'm doing that is because I can easily multiply both sides by cosine squared. So when I do that maneuver, I get my d theta dt by itself, and I'm going to have x dy dt minus y dx dt. Okay, get your paren now, and then that whole numerator is multiplied by cosine squared theta, and then the whole thing is divided by x squared. Okay, so let's see what we have. We can start plugging in our numbers. So what do we have for x? X was that missing side that we found, 173.2. What is dy dt? Remember, dy dt, the height stayed uniform, so that's actually going to be 0. So that's kind of nice. That's going to fall away. Okay, so let's do that in the above so that I have less to write down. So because dy dt is 0, therefore that first term goes. All right, and I'll erase what I wrote here because there's no reason to really write that out. So what do I have now for my first term? Okay, returning back to my blue, my first term is going to be a negative, right, because I have the y coming at me now, and the y is 100, so negative 100. The dx dt was given, and that was just plain old 8, and then I'm going to multiply that expression by the cosine, and the angle I found was 0.52, so 0.52, and I'm going to have to square that all over my x is 173.2 squared. Okay, so go ahead and do that math. Carefully put that in your calculator, and you should be getting that the angle is decreasing at a rate of negative 0.02 radians per second. And there you have the third problem. So I'm going to just circle that in red. This is d theta dt, and there is our answer. Okay, let's move on to the fourth and last problem. Okay, so let's begin reading. An observer stands 800 feet away from a launch pad. So that means this is where my observer is. The rocket blasts off and maintains a velocity of 1,000 feet per second. So if this is going to be my x, then this will be my y, and my dy dt is going to be 1,000 feet per second. Okay, let's continue reading. Assume the scenario can be modeled as a right triangle. Okay, so that's our right angle. How fast is the angle of elevation, and that's this angle right here, in radians per second from the observer to the rocket changing when the rocket is 600 feet, so that's my y value, off the ground. So I want to find d theta dt, but before I do that, so that's the whole focus of my problem, but I'm missing some things. So what am I missing? I'm missing theta, and I'm missing dx dt. So since that observer is not moving, we can assume that dx dt equals 0. So now I'm just missing the angle before I can start the problem. So look what I have. I have opposite and I have adjacent. So that means it's going to be a tan. So let's use tan of theta, and theta is missing, equals opposite. So that's going to be 600 over 800. Let me go back and not do it this way. So let me put my variables in for everything first, just like I always do. So this is y over x. Okay, so this is my equation that I'm going to use twice. I use it the first time to find the missing angle. So now I say tan of theta equals 600, that's opposite, over 800. So that's just 3/4. So when you take the inverse trig, when you say tan to the -1 of 3/4, you will get an angle that's equal to 0.64 radians. Okay, so now we have an angle, 0.64 radians. Okay, so let's do what I've been normally doing. Let's eliminate this work, and we'll use this place to do our related rates equation with the exact same relationship. So take the derivative on the left and the right. So that's going to be secant squared theta. Don't forget to do the d theta dt equals low d high minus high d low all over low squared. Alright, so before we start plugging in, I know that dx dt, so right here, that's 0, so therefore this whole expression is going to go. Okay, that's going to make that easier for me. Okay, the other thing I know is that it is easier writing this as 1 over cosine squared theta. Alright, so I just did that. So I'm going to multiply, in a second I will multiply both sides by cosine squared theta to get rid of that in the denominator. So let's do that now. So doing that to the left, so let me just go back to my green. So doing that on the left ends up eliminating the cosine squared theta from the denominator. So I multiplied the left by cosine squared theta. That makes that a fancy 1. Do the same thing over here. So I'm going to multiply by cosine squared theta. I'll write it out for you here. So I'm going to get d theta dt by itself. That's going to equal, I only have x dy dt left, and then that's going to be multiplied by my cosine theta, and then I'm squaring it, all over x squared. Okay, so now we're just going to be plugging in our numbers. We ultimately want to find d theta dt. So what is our x? So our x was the 800. So 800 dy dt was 1,000 feet per second, and we should check our units. Everything is okay because we're in feet per second for all the rates of change, and we're in feet for all the measurements, so that all works out. Okay, so then times the cosine, and the angle we found was 0.64. I am going to square that little guy, and then the whole numerator is divided by x squared, which is 800 times another 800. Okay, the reason why I do that is just going to make it easier to cancel. So what do I know? Well, this 800 and this 800 can cancel. And it looks to me like I can get rid of these zeros, and 10 over 8 is really 5 over 4. So in your calculator, you're going to say 5 times the cosine of 0.64, and then square only that trig term, and then divide the whole thing by 4. And when you do all of that, you will get your final answer, which you should be getting as 0.80 radians per second. All right? So we've now gone through 4 angle examples. So I'm going to box off our final answer. So this is what I have for d theta dt. So these 4 angle examples should help you to do the last two problems. So that's 11 and 12 on the blue packet. So go back and look at that now. These 6 problems, okay, these 4 plus the 2 from the blue packet, should allow you to do the project, okay, that you'll get after the Chapter 3 test. So know where your resources are. Make sure you have this all nicely written out. I have posted this handout on the portal so you can print it out and then fill it in nice and neatly if you weren't as neat in class. And just listen to it, systematically. Know that you are using your trig relationship twice in each problem. All right? So that should help.